Cool, so a little bit of a story time, just to kick off this talk on security. I'm going to tell you a little bit about my favorite vulnerability. So it all happened in 2008, and that was a really good year for tech and web. Google released Chrome, and everyone was very excited about that, a competitor for Firefox, although I love Firefox. HTML5 was introduced, and the first ever Android device was released. It was also a very interesting year for the security community because some people discovered a way to embed a jar file, an executable jar file, into a GIF. And that caused quite a bit of a stir because no one expected that an image would be able to cause such a big vulnerability. And Java is quite a powerful language, so you can only imagine the extent of this. In 2012, people didn't completely abandon the idea of using crazy things like images to attack users. So they went ahead and discovered a way to embed actual executable code, not just archives, into images. And they created something called an image.js attack. And in the example there, I'm pretty much embedding like a PHP script into an image. And I'm taking advantage of the fact that the browser knows that your file is an image just by looking at the header. And then there's a bunch of like blob of just like nothingness junk that the browser ignores, and then there's the actual content that makes the image. So in that blob of junk, you can pretty much put anything there, and this is a script that says, hey, it's a lovely day, isn't it? So let's see why that is bad. Well, say I have an app that allows users to create and upload all sorts of content, for example, images. There's nothing stopping an attacker from uploading this image into a very nice URL, so it's just kitten.jpg, and then link it to, well, the same URL, except at the end of it, instead of JPEG, we have .jpg.php. So assuming that that website is actually running PHP, when I click on the link, well, guess what would happen? My script would run. And instead of being able to download this cute kitten image, you're just saying, hey friend, from IP, it's a lovely Monday afternoon, isn't it? This was actually in my hotel yesterday, so that's why it's Monday, and that's the actual IP of the hotel. So if you want to play with this, see how it works, I have it just on GitHub with all of that. What's particularly bad is if you notice the URL, it's actually running a script that it shouldn't under a website that, well, it should do something else, right? And that's bad because something called the same origin policy, which if you don't know what it is, I strongly recommend you do some reading on it. But it's one of the most important web application security policies and ideas. And it basically it tells the browser that if a script runs on the same origin as the website that you're on, then it should have access to all sorts of crazy information, like, well, let's just say your user data, which is pretty serious, and it's what allows people to impersonate you, right? So yes, cats are planning to kill you, or at least steal your identity and your money very soon, which is very sad because I love cats. But it kind of goes to my point of, like, you never know what people are going to come up with, and they're quite inventive in ways that they're going to attack your app, so you never know. And it plays very nicely to the first rule of web security, which is never, ever, ever trust user submitted data, ever. There's no guarantees. It doesn't matter if it's an image or like sound or anything, just never, ever trust it. Okay, part 2 of the story, I'm going to tell you a little bit more about Intercom. So in Intercom, we have a 4-year-old Ember app. And if we look at the stats from, just to kind of understand the magnitude of this, if we look at some stats from last week, we have 37 authors that submitted a total of 190 commits to master, and 220 across all branches, which resulted in a total of 892 file changes, with more than 5,800 additions and almost 16K deletions. So it's a pretty big app. And on top of that, shipping is at the heartbeat of Intercom, so we are shipping to production more than 100 times a day. The back end of our app is Rails, so everything that we're going to talk about today, I'm going to try to talk from the perspective of a very mature app. A little bit about me. In 2016, I started working with Ember, and about 3 months later, I had to fix an issue around uploading uploading in real-time preview of an image without introducing an excess vulnerability in the code. Now, my background is like infra and backend, so I kind of went like, what does all this mean, especially because our app is huge, and decided to look more into it, and I guess, well, here we are today. So this talk is going to be a too late didn't read list of things that I wish I had back then. Some ranting about linters and regular expressions, and a way in which I think engineers can help with the security of an application. So again, all put into the context of like a very mature Ember application. Cool. So the first thing that you do when you don't know what to do is prepare for battle and get to know a little bit more about your enemy and what all of this means. So something that I think is really, really important before you start and before you dive into something that's like very theoretical, because security tends to be that way, is to know a little bit about user input and understand what you expect from your users. And then know a little bit about the same origin policy, because everything that executes on the web will follow that rule. Know a little bit about the content security policy and why it's such a powerful tool. We're going to get into that a little bit later. Know your browsers, know your tools, so the security features on your browsers. And what does HTML as input even mean in Ember? And how does Ember do that? So that's what we're going to try and focus on today throughout the talk. Oops. Yay. Back. Cool. So let's look a little bit into what a vulnerability, like where an injection attack actually looks like. So say we have this API that allows me to search for coffee, and then it returns a list of results that are displayed in your browser. And the top of that list is just something like results for coffee. And an attacker sees that and kind of goes like, that coffee matches the search term that the user, I submitted. So I wonder what would happen if I actually use a script to search for it. Now, in the modern browsers, if you just do a script alert, the browser is smart enough to say, hey, you probably shouldn't be doing that, and it's going to block it. However, in older versions of the browsers, by older I mean like about a year ago, Internet Explorer was still struggling with this. So if instead of passing just a script with an alert, you'd pass something that's slightly malformed, which is this image tag with like 3 quotes that doesn't make any sense. The browser is going to go, I don't know what to do with that, so I'm just going to run it. So, yep, it's not scary at all. So it actually runs, and you know when you have an alert, you don't really care. I mean, it's a bad user experience, but it's minor. The real problem is that you can do something like document.cookie. And what document.cookie returns is actually the content of your user document. And that becomes a problem if it's in the wrong hands. So this is something that's called a reflected XSS. This is kind of how it looks like, and you can pretty much just spin up your own server and try this on your own. Cool. So now that we know what we have to deal with, let's prepare our spells and look a bit into how we can address all this. The first thing that we're going to look at is Ember. We are a modern web application, so we want to use a modern framework, right? And in this case, we're using Ember. So it's very important to know how Ember does HTML escaping and how it deals with user content. And then we're going to look a little bit into the content security policy and why it's so powerful. So what Ember does as a way to protect you against injection vulnerabilities is actually, by default, escape all the HTML. So the Ember rendering layer, whenever you basically return a piece of HTML from your helper, because why not, you can, it's going to go, I don't think you want to do what you think you want to do, so I'm going to escape it for you just to keep you safe. And that looks pretty much like this. So if I have a helper that returns a cat image, and I'm returning just the image tag with the source as it is, Ember's going to go, nope. So instead of seeing a cat image, you're just going to see the string of what you returned. If you want to see an actual cat image, you have to tell Ember explicitly that that HTML is safe to display. And you can do that with Ember string HTML safe, which is also a very bad thing that you shouldn't be doing, and we're going to get into that a little bit later. But if you want to, you can. So when you're doing that, Ember says, oh, you actually wanted an image. And it's going to show you the image of a cat reading military strategy, which is pretty much what we're doing right now, I guess. And again, there's a gist on GitHub, so if you want to play with this, see how it works. It's all there. Cool. So now that we know a little bit about Ember, what the hell is a content security policy? Well, in 2004, people kind of went, I'm kind of tired of this XSS attack. Is there a way to mark what is safe to run and what is not? So the guys at Firefox, yay, Firefox, were the first one to implement like a somewhat version of the version 1 content security policy. And then it became really popular and other browsers became interested. So in 2012, they actually went on and released the first version of it. And it's a very powerful and very good way to say this script is safe to run. and everything else is not. So you can whitelist what your app considers to be safe. The content security policy gets returned pretty much as a header in a HTTP request that tells the browser, hey, here's a list of scripts that I think are safe. And the browser is going to read that and say, oh, OK, so everything from self and startingmysite.com is safe. I see someone's trying to embed this pure evil. I'm going to go ahead and block that because that looks wrong and it's not part of your security policy. The very powerful thing about it is that it will also stop you from, it will also stop inline scripts, which is the last example when someone's trying to run a script taking it as an image. So too late didn't read because this is kind of a talk on its own. There's an Ember CLI add-on from Robert Jackson that, if you don't have usually the content security policy is something that you take care of at the server side. But if you're just running an Ember app and that's it, go read that. It's very powerful. It's a pretty good tool. And keep in mind to always use the content security policy version 2 of version 3. Version 1 was a little bit of a interesting conversation where people couldn't decide what inline scripts shouldn't do, so it's a little bit of a mayhem. Just to be safe, do that. But version 2 was I know how to fix it, so they introduced hashing and ways to validate that an inline script is what it is. And there's a really good documentation about it, so the content security policy and the consortium did a very good job at putting together documentation, so you can go ahead and do a bit of reading on that. Cool. So with our theory in mind, let's see how we write better code, right? Because that's kind of the point of all of this. So we're going to look into eradicating HTML safe and writing better helpers. So you should avoid HTML safe at all costs. Why? Well, because you can never really vouch for the content that your user is going to submit. You have to make a lot of assumptions, and that's pretty scary. And the risk of missing something increases with the number of assumptions that you're going to make. So a better way, to not worry about it, try to avoid HTML safe and figure out better ways to rewrite your code. Never use directly on user input, and your controller should not HTML, ever. You shouldn't have HTML in your controller. It doesn't belong there. And as a power up, there's contextual components. So let's say I want to just write a very simple card component that has a title and a content. And that works for a very long time. And then someone comes along and says, hey, I actually want a name input, and I want to say hi to that person in the title. Can you do that? And the answer is, well, you can. And for a very long time, this was the way this was addressed, where you'd have just a card component that takes a title and then the content part of it. And then in your controller, you'd say, OK, I want my name to be displayed with bold. So it's going to return a HTML safe, hi, name in bold, and that's it. And that is pretty bad because it could potentially introduce a vulnerability. You have no control over what your name is. So a better way to rewrite this is using contextual components. And again, this can probably be a talk or a tutorial on its own. So I'm going to give you the basic, and then if you want to read about it a little bit more, there's the Ember map has a really good tutorial on that. So I'm going to rewrite my component using these yielded properties, so then I can access the card title and the card body directly. And the reason why I want to do that is because the title and the body have two separate functions, right, and two separate roles. And I want to be able to be a little bit more opinionated about that. And if I want the title to be just a simple string, then I can do that. And if I want the title to do something crazy, like say hello to a person, then I can do that as well. So I'm just using the card properties, title, and the body to just tell them what to do. And it's going to look something like, hi, Hermione, in bold, and just a text to, well done, Harry. This looks significantly better. If we look at our supercard component and how that is implemented, it uses this hash helper to actually yield two components. One component for the title that will take care of displaying Hermione or EmberConf or whatever we want in there. And then a body that will just yield whatever content we want as well. And if this component gets a title as well, then it's just going to call the title component with that title and let the component take care of that. So it becomes so much simpler. In our body, we don't want to do anything fancy. We just want to yield whatever content we have. And then on our title component, on the child title component, if it has a block, so if I just want to display something very simple like, hello, I'm very excited to be here, which is true, then I'm just going to yield that content. And if I need anything, if I have the something more complicated like HTML, then I can do that as well. Cool, so that takes care of using the name and the title. If, like I said before, if I just want something very simple, which is EmberConf, then I can just pass the title to the supercard component and have it take care of how to display it and where to display it. So I don't have to tell Ember what things are safe to display and where it should be anymore. It's gonna take care of that itself. And I'm just calling the so card.body and passing the whatever content that I want displayed on the body because I already have a title. So it's just a much nicer, much more deliberate way of displaying content, and it involves less hacking to be able to accommodate future usages. So if I want to change this into displaying an image or whatever the hell I want to do after that, it's very easy to do it with this. I don't have to worry about it anymore. So contextual components are quite powerful. I feel very bad that I'm not able to cover more of this, but do go and do some reading on them. They're awesome and allowed us to lower the number of HTML saves in our app. Cool. Something that's also very important is writing good helpers. If you remember my very cute cat image that returns HTML, ideally you should prefer updating the DOM over having HTML and helpers. And let's say you want to write something that wants to return a user email or a helper to allow you to like send an email. Well, the way you'd previously do this is that you'd have to sanitize the user input to make sure that there's nothing crazy going on there. And then you'd have to use HTML safe to tell Ember that, hey, this is actual HTML. I vouch for this, and you shouldn't touch it. And that's kind of scary because you cannot, like, it can introduce unexpected behavior, and again, it runs on you making assumptions about your content. So a much better way to do this is to use the DOM directly to create a text node, and then set the style attributes if you have to, because you can, and it's very simple. And then append, let's say you have an anchor in this case, so append the anchor child element, return the node, and then that's it. So let's look at let's look what all this means in code, right? So you have this good mail to helper, and it takes a parameter, an email, a name, and a class if you want to style that email. And then I'm going ahead and creating an anchor tag element. I'm setting the target to blank. I'm setting the reference to the user email. I'm setting a class name if that was provided as a parameter. And then all the magic is when I'm creating the text. So I'm creating this element as a text node and letting the browser take care of all the escaping and all the displaying, and just say, hey, browser, always treat this as text rather than me having to like be deliberate of is it HTML or is it text or whatever. So just don't worry about it, browser, worry about it. And then I'm appending the text child to A and then just returning it. And it's a much nicer way to, again, just worry less. Worrying less is good. Cool, so now we know how to write we know how to write better components and we know how to write better helpers. But we have templates as well. And turns out you can escape HTML on your templates. And we're going to also talk a little bit about target blank and what that means and why it's a very bad idea to use on its own. So escaping, we've already kind of established that escaping HTML is very dangerous. And what triple curlies is basically HTML safe for templates. And you should never use directly on the user input. And in fact, you should be always deliberate and mindful about what you vouch for. But the reality of it is that you should never, ever have to find yourself in a situation where you have triple curlies. If you do, then you should probably consider refactoring some code with contextual components and good helpers in mind. And good helpers plus contextual components would actually allow you to not have to have triple curlies in your code anymore. And if you do, please go and refactor it. Target blank is probably one of the most underestimated vulnerabilities in the security in the security community. And I guess the too late didn't read rule about this is that you should always use target blank with no opener and no refer as attributes. And the reason for that is when you specify target blank, that tells your browser that, hey, the next page should have access to a bunch of window objects, especially window object and window opener and window opener location. So it allows the page that you're linking to have access to the location and change it if you want to pretty much whatever it wants. It can be a phishing website, it can be something completely safe, it can be something completely unsafe. Some of the permissions will automatically be negated by the same origin policy. So if it's a different origin, that it won't have access to your cookies or anything crazy like that. But window location is fair game, and it's a very good way for people to redirect you to whatever website they want. The problem with this is that browsers tend to have different opinions when it comes to no opener and no refer. And by that I mean that Firefox decided to not implement no opener until, well, version 54 that's going to be released at the end of this month. So if you only have one of them in your code, then you're actually letting users that prefer a browser over the other a little unprotected. And what's even funny is that Instagram suffered from this vulnerability until last year, when someone wrote a very raging blog post that became super famous overnight and went, hey, Instagram, could you actually fix your stuff? So this is how, so to make sure that if you support Firefox or a large range of browsers, then you should always use rel no opener and no refer in your templates. And a very good way to detect that is using the Ember template lint by Robert Jackson. And for those of you that are familiar with this, the linter used to validate for no opener or no refer. And there's been a patch submitted this week to actually validate both. So all you have to do is make sure that you're on the latest version, and then switch from true to strict, and make sure that you also fix your code if that's the case. Otherwise, you're going to see a bunch of errors. But it's going to allow you to make sure that both your users are protected. And it also provides detection for triple curlies. So it's quite a powerful add-on. I strongly recommend you go and add it to your project. Cool. Now that our code is a little bit better, how do we keep it that way? So I'm going to talk a little bit about static analyzers, which is my favorite thing to rant about these days. And we're going to talk about ESLint. We're going to talk about why regular expressions are evil, and I hate them with passion, and why setting watermarks or lines in the sand for where you are from a security point of view is a very good and very sane thing. So first, the story. Before ESLint, there was grep. So we had this idea of checking for the occurrences of HTML safe in our code using grep, because you can. And we built a tiny add-on that uses a post-built hook to get real-time feedback in dev about whatever it is that you want to check. So it's a combination of find plus grep plus regular expressions plus WC minus L, so word count lines. And compare the count against the static limit that's been preset. So say you have HTML safe 5. And now when it runs, if HTML safe is at 6, then you have a problem. And then fail the build if the numbers don't match. And this was built with getting engineers real-time feedback in dev and giving them an opportunity to address those changes, especially if it involves refactoring. You don't want to find out about it when you're running in CI. You really don't, especially if you have to fix something and fix it fast. And that worked fine, but hey, regular expressions are a little bit like black magic, and you do kind of have to sell your soul a little bit to understand them. I know there's people doing crazy things with regular expressions in Perl. I won't go into that. But personally, and the reality of it is, whenever you have a regular expression, it makes that much harder to maintain your code. So it does work, it is fast, but it's not ideal. So we looked into a way to do this a little bit better using ESLint. And we thought, hey, could we maybe use linters for real-time feedback and figure out a way to plug it all in and have the same line in the sand, but instead of using grep, using linters to make it a little bit more maintainable. The problem with this is that linters are notoriously, or could be notoriously slow, especially when you run them on thousands of files. So we definitely didn't, our main concern for this was, would the linter be fast enough to be able to run real-time in dev? So the main idea was to write a custom rule that checks for blacklisted methods. So it would get an argument of a list of blacklisted methods that you want to check for, like HTML safe, and then use the ESLint running engine to get a count for that. So the ESLint, for those of you that are not familiar with it, relies on something called an AST tree, and then it parses that tree and checks for whatever it is that you're interested in. So in our case, it's a function, which makes it a call expression in ESLint land. And it's looping through all the blacklisted methods that you got as an argument. And if it finds one, it's going to throw an error saying, hey, this method has actually been blacklisted and you shouldn't use it. Cool, so now we have the rule that runs that. How is it going to run, right, in the code? So we're going to use we use the ESLint CLI API plus the custom rule that we just built to get the counts for different blacklisted methods. And then allowing ESLint to actually cache, so in dev to actually cache all the runs to make it faster. And it turns out it's actually, like the performance difference of like using cache and not using cache is between 10 to, I've seen something crazy like 60 seconds on like slower machines. So caching is something that's very, very important for ESLint, which means yes, on a colder build, you're gonna have some issues, but if you're not running for the first time, you should get quite good performance results with caching. And then fail to build if the error count is bigger than the max allowed. And this is kind of what it looks like when you run in dev. So the first time, there's no problem. It runs just fine. And then I'm updating this new .js and using HTML safe because I don't know any better. And then I see a big red error on the screen going, hey, actually, you've just introduced a new HTML safe vulnerability. You probably shouldn't do that. So it allows the engineer to go, oh, actually, fair enough, and go and refactor the code, make the change, and then it rebuilds. If you're looking at the rebuild time, we're at 1.3 seconds, I think. So it is pretty fast to be used in dev. And you can also, this is just taking advantage of the post-build hook, but there's nothing stopping you from running it in CI as well. So if you don't really want to deal with configuring all this, we are working on an add-on to blacklist methods. So I guess follow me on Twitter or Intercom Engineering, and there's going to be more news about this in the following days. So yep, we got your back. Now that your code is better, you have a lot of information to keep going, you know what to do. It's generally a really good idea to like throw an eye in the community and see what happens and basically consult with other wizards. A really good resource is the OS Top 10. What they do is check every year and create a top 10 of like the most common vulnerabilities. Shocking, XSS is still at the top of the list. And then broken authentication and session management used to be, I think, not on this list, or at the very bottom of this list about 3 years ago, and now it's at the very top, so that should probably make a lot of people start worrying. And something else that we've done is run bug bounties in Intercom. So up until February 2016, we had a private bug bounty, and now it's a public one. It's a very good way to invite security experts to test your code and get a better understanding of where you are. So thank you very much.